20 amp receptacle on a dedicated circuit is tripping when a 15 amp mitre saw is plugged directly into it, but not when using a 50-foot extension cord. There are several possible reasons for this issue. Firstly, the receptacle itself may be faulty. Loose or damaged connections within the receptacle can cause voltage drops, which in turn trigger the breaker to trip. Secondly, loose connections in the electrical box behind the receptacle could be the problem. It's important to check if the wires in the electrical box are securely connected and not loose or disconnected. Thirdly, voltage drop due to wire length plays a significant role. Using a 50-foot extension cord actually reduces the voltage drop from the circuit panel to the outlet, potentially providing better power to the saw despite the added length. Fourthly, circuit overload is a common cause. While the saw has a 15 amp draw rating, it can draw significantly more power when starting up or under heavy load. The dedicated 20 amp circuit may not be sufficient to handle this surge, especially if there are other loads on the same circuit. Fifthly, a ground fault in either the saw or the extension cord could be the culprit. A ground fault occurs when current leaks to ground, causing the breaker to trip as a safety measure. Sixthly, overheating of the receptacle may occur when the saw is plugged directly into it, causing the breaker to trip. Heat buildup can indicate a problem with the receptacle's internal connections. Seventhly, some mitre saws have capacitors that store electrical energy when plugged in. When the saw is plugged directly into the outlet, these capacitors may draw a momentary high current, which can trip the breaker. Now, let's discuss suggested solutions to resolve this issue. Firstly, replace the receptacle with a new one, ensuring proper and tight connections. This eliminates the possibility of a faulty receptacle being the cause. Secondly, carefully inspect the electrical box for any loose or disconnected wires. Rectify any issues by tightening connections or replacing damaged wiring. Thirdly, try using a shorter extension cord, ideally less than 10 feet, to minimize voltage drop. This helps to provide a more stable power supply to the saw. Fourthly, consider upgrading the electrical circuit to a higher amperage, such as 30 amps, if the saw is consistently tripping the 20 amp breaker. This provides more headroom for the saw's startup and operating current. Fifthly, rule out a ground fault by testing both the saw and the extension cord using a multimeter. This will identify any potential leakage current to ground. To perform this test, firstly, unplug the saw and the extension cord from the power source. Secondly, set your multimeter to measure resistance in ohms. Thirdly, connect one lead of the multimeter to the grounding pin of the plug and the other lead to the metal frame of the saw or the grounding prong of the extension cord. A reading of infinite resistance, or a very high resistance, indicates no ground fault. A reading of 0 ohms, or a very low resistance, indicates a ground fault. If a ground fault is detected, have the saw or extension cord repaired or replaced by a qualified electrician. Sixthly, ensure there is proper ventilation around the receptacle and outlet to prevent overheating. Clear any obstructions that may be blocking airflow. Seventhly, consider using a soft start power cord. This type of cord can limit the initial surge of current when the saw starts up, reducing the risk of tripping the breaker. Soft start cords gradually increase the voltage supplied to the saw, minimizing the inrush current. Additional points to consider are the type of breaker being used. A standard thermal magnetic breaker may be more prone to nuisance tripping compared to a more sensitive breaker type like an electronic trip breaker. Also, check the voltage at the receptacle while the saw is running. A significant voltage drop under load indicates a wiring issue or an overloaded circuit. Consider using a dedicated circuit tester to check for wiring problems such as open grounds, open neutrals, or reversed polarity. These issues can cause the saw to draw more current and trip the breaker. Furthermore, the age of the breaker is a factor. Breakers can weaken over time and become more susceptible to tripping. Consider replacing the breaker with a new one of the same amperage rating. When working with electrical circuits, safety is paramount. Always disconnect the power at the breaker before performing any inspections or repairs. If you are not comfortable working with electricity, consult a qualified electrician. To further elaborate on voltage drop, it is a decrease in voltage that occurs along a conductor as current flows through it. The longer the conductor and the higher the current, the greater the voltage drop. The formula for voltage drop is volts drop equals current multiplied by resistance. The resistance of a wire depends on its material, length, and cross-sectional area. Copper wires have lower resistance than aluminum wires. Thicker wires have lower resistance than thinner wires. To calculate voltage drop, firstly, determine the current flowing through the circuit. This is typically the nameplate current of the appliance or tool being used. Secondly, determine the resistance of the wire. This can be obtained from wire tables or calculated using the formula resistance equals resistivity multiplied by length divided by area. Thirdly, multiply the current by the resistance to obtain the voltage drop. The National Electrical Code, NEC, recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. Excessive voltage drop can cause appliances and tools to operate efficiently or even fail. In the case of the miter saw, a significant voltage drop can reduce its power output and cause it to draw more current, potentially tripping the breaker. To minimize voltage drop, firstly, use thicker wires. Secondly, shorten the length of the circuit. Thirdly, reduce the current flowing through the circuit. This can be achieved by using energy-efficient appliances and tools. To elaborate on circuit overload, it occurs when the total current flowing through a circuit exceeds the circuit's rated capacity. This can happen when too many appliances or tools are connected to the same circuit. Circuit breakers are designed to protect circuits from overload. When the current exceeds the breaker's rating, the breaker trips, interrupting the flow of current. To prevent circuit overload, firstly, avoid connecting too many appliances or tools to the same circuit. Secondly, use extension cords sparingly, as they can add resistance to the circuit and increase the current draw. Thirdly, consider using a power strip with a built-in circuit breaker to protect against overload. Furthermore, the type of load connected to the circuit can also affect the likelihood of overload. Resistive loads, such as heaters and incandescent lights, draw a steady current. Inductive loads, such as motors and transformers, draw a surge of current when they start up. This surge current can be several times higher than the running current. The miter saw is an inductive load, so it will draw a surge of current when it starts up. This surge current can be enough to trip the breaker, even if the running current is well below the breaker's rating. Soft start devices can help to reduce the surge current of inductive loads. These devices gradually increase the voltage applied to the load, limiting the inrush current. Ground faults occur when current leaks from a live wire to a grounded surface. This can happen if the insulation on a wire is damaged or if an appliance or tool is not properly grounded. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electric shock by detecting ground fault. When a ground fault is detected, the GFCI trips, interrupting the flow of current. GFCIs are required in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. To test a GFCI, firstly, press the test button on the GFCI receptacle. The receptacle should trip, interrupting the flow of current. Secondly, press the reset button to restore power to the receptacle. If the GFCI does not trip when the test button is pressed, it should be replaced. When using extension cords, it is important to choose the correct gauge of wire. The gauge of a wire is a measure of its thickness. Thicker wires have lower resistance and can carry more current. The NEC specifies the minimum wire gauge for different circuit ampacities. For a 20 amp circuit, the minimum wire gauge is 12 American wire gauge, or AUG, copper. Using an extension cord with a smaller gauge wire can cause voltage drop and overheating. It is also important to choose an extension cord that is rated for outdoor use if it will be used outdoors. Outdoor extension cords are designed to withstand the elements and are typically made with heavier gauge wire. Another factor to consider is the length of the extension cord. The longer the extension cord, the greater the voltage drop. For long extension cords, it is important to use a heavier gauge wire to minimize voltage drop. Also, inspect the extension cord regularly for damage. Replace any extension cords that are frayed, cracked, or otherwise damaged. Never use an extension cord that has been modified or repaired. Also, avoid overloading extension cords. Do not plug multiple appliances or tools into a single extension cord. Overloading an extension cord can cause it to overheat and potentially start a fire. Always unplug extension cords when they are not in use. This will help to prevent overheating and conserve energy. The information provided is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before performing any electrical work.